So in this lecture, we're going to talk about the time value of money, specifically focusing on unequal multiple payment values. All right, so how do multiple payments of unequal value present themselves in everyday situations? So a lot of times we deal with cash flows that have regular payments, as we saw in the previous lecture with annuities and perpetuities. But a lot of times we'll have multiple payments of value that are unequal. These are much more common and more likely to occur. For example, a risky investment might generate a different cash flow each year as a function of the riskiness and unpredictability of its underlying operations. When in doubt, it's best to evaluate individual cash flows as separate lump sum cash flows, as we did 2 lectures ago, in order to make sense of them. So recall how we calculate the future value of a cash flow. The future value, FV, is equal to PV times 1 plus R raised to the n, or the present value multiplied by 1 plus the interest rate raised to the number of periods, or n power. Okay. So when cash flows are uneven and uncertain, this is our default approach. We'll treat each individual cash flow separately as a lump sum payment, use this formula, and then add everything up at the end. When cash flows are uneven and uncertain, and we want to know the present value of multiple payments of unequal value, we can use the previous equation, doing some algebra, and rearrange it, or just use the formula that you see now present on the screen. PV equals FV over 1 plus R raised to the n, where PV is equal to present value. We set this equal to FV, the future value, divided by 1 plus R, the interest rate, raised to the n number of periods power. So financial calculators have a cash flow or cash flow function that allows you to input future cash flows in their sequence. The order with which cash flows are entered spaces them out and identifies the period in which they occur. You would then be able to solve for present value or future value once the data has been input and a discount rate is provided. You can as well solve for a discount rate that equates the present value of the individual cash flows to zero. So for example, this is known as the internal rate of return, or IRR, which is the bond equivalent known as YTM, or yield to maturity. You can also deal with each cash flow as an individual lump sum and sum their present or future values if given a discount rate. A best practice would be to create a table that shows cash flows in a time continuum, identifying cash flow events in their sequence. To use Excel, a cash flow diagram showing how cash flows are spaced out over time is essential in evaluating them. Uneven cash flows will not allow you to use annuity or perpetuity methods, as they don't fit into this definition. If you're evaluating the present value of future uneven cash flows, you can use Excel's NPV function. However, note that the NPV function starts at time 1, so you would need to remember to add the year 0 cash flow at the very end, because the sum that's generated does not include the year 0 cash flow. Yours truly has seen many instances where students and businesses that I consult with have made this error. Okay, so the IRR function, where you can use to find the interest rate on uneven cash flows, allows you to put in the year 0 cash flow automatically. So you just highlight all the data, but you cannot do this with the net present value function. I'm hopeful that this will change in the future, but it has been in existence since Excel was created, so I don't believe this is going to change. Feel free to check out my YouTube video that talks about how you can create your own functions in Excel to perhaps create a better NPV function if this is something that you're using in your day-to-day business. So let's now review the basics of the Excel file from this chapter, as well as some of the topics we talked about here. So I'll first review the figure 9.2. So in this example, we have an assumed interest rate of 7%. Nothing happens in year 0. We have 7 years. In this example, we have decided to invest $2,000 at the start of every year for the first 3 years, then $12,000 in year 4, and then $5,000 in year 6. So the total amount of money that we invest is $27,000. However, this does not take into account the time value of money. So what we do is we calculate the interest on the balance every year, and we add up the principal plus the interest. So we can see over time, we don't wind up with 27,000, but at a 7% interest rate, all the interest on that account, plus all the things that we add up over time, you'll just over $8,000 in interest with a total cumulative cash flow of over $35,000. So note in Excel, you have to put percentages in this notation, 7% or 0.07. To multiply, you use star or asterisk. To add, it is the plus sign, or you could use the equal sum function, as we see here. And then also note we can use the net present value function to solve. So here what we do is we type equal NPV, parentheses, C1, which is the interest rate, and then C3 to I3, those are our cash flows. And then the way they've done this here is they put plus M7 on the outside of the equation and come over here to M7, that's nothing. But it probably would be better to actually do that, change that M7 to be here, because that's the cumulative cash flow at time 0. But note what I usually do is I close out the function and then put that on the outside. So there's multiple ways to do this, but that's an example. So this would be the present value of this investment at 7%. Excuse me. So figure 9.6, this looks at desired withdrawals and interest rate. So for this one, maybe we're trying to figure out how much money we need in an account today, such that we withdraw all this money at 6%, and we want to make sure we have enough money. So years 1, 2, and 3, we withdraw 17,000, and then years 4 and 5, it's 17,500 and 18,000 respectively. So we use the net present value function to solve that equation. As you see here, where B3 is the interest rate and C2 to G2, those are your cash flows. And note, anything that's in year 0, which in this case is 0, would need to go on the outside of the function. Now let's look at one other example. And this will also kind of show you the steps if you're using a financial calculator, which you don't have to. I'd recommend Excel. But here is an example, and then I have one final note for you all. So typically when you're beginning your work, make sure you start with a blank, clean worksheet, or you clear the memory out from your calculator in terms of any cash flows. So what we'll do, our first cash flow at time 0 will just be 0. So we type in 0 and then hit enter and then down to your next one. So this next one, we'll call this C01. So this will be 17,000. Type that in and hit enter to go to the next cell, or in your financial calculator. If you're using a financial calculator, you would do something similar. You type in the number, hit enter to make sure it's locked in, and then go to the next cash flow. You can hit the down arrow twice generally to get to the next entry, because in financial calculators, they'll have an F sub 01, which stands for frequency. So if it happens more than once, feel free to change that. But typically I tell students just to hit down twice to skip that. Even if cash flows happen, like say, for example, the 17,000 happens multiple times, or it happens at different points in the timeline, you need to make sure that everything is done in order. Okay, so I would just recommend hitting down twice on that. So now C02, the second cash flow, is going to be another 17,000. C03, let's say that is another 17,000. C04 is 17,500. C05 is 18,000. If you're using a financial calculator, there will be an NPV button that you hit, and then you'll input the interest rate, I. So for our example, this is going to be 6%. In Excel, you put in 6% or 0.06. On the financial calculator, you can just type in the number 6. Okay, so now we're going to calculate the NPV. So if you're using a financial calculator, once you enter the interest rate, you hit down, and then you hit the CPT key to compute, and then you're done. In Excel, we'll type equal NPV parentheses. And if you want to use the FX, click the FX here. This will pull your function up to the right side of the screen. You don't have to do that, but you can. So the interest rate here is going to be cell B7, which is 6%. And then my values, you can click one of these at a time and add them, or you can just highlight all of them. So that's what I'm going to do here. And then I will do plus that 0 on the outside of that there. Okay. So just make sure that the function just calculates the NPV from times 1 through 5. And anything on the outside of that would be there on the outside of the function, or probably better yet, I would put it here to where I know that it's definitely for sure outside the function. So once you do that, you should get $72,753.49. This means that for this investment with these cash flows, assuming a 6% interest rate, I would be willing to pay $72,753.49 for this opportunity today. Another way to interpret this would be I need to have $72,753.49 in my bank account today, such that at assuming a 6% interest rate, I can withdraw $17,000 a year from now, $17,000 2 years from now, $17,000 3 years from now, $17,500 4 years from now. So then in year 5, I will close the bank balance out by withdrawing the final $18,000. So a couple final notes for you. In dealing with multiple uneven payments, the easiest way to deal with these is to treat the cash flows as individual payments. As with all problems involving time value money, I would recommend you get in the habit of creating a cash flow diagram that shows the magnitude and sequence of cash flows spaced out over time, and or create a table that identifies the independent variables and the dependent variable, or the thing that you're solving for. In this case, each individual cash flow. Once you break this down into individual cash flows, time value money problems come down to PV or present value, FV or future value, N, the number of periods or typically years, and then I, or the interest rate. Note that payments only apply to annuities, so they will not appear in these types of problems. Financial calculators are well equipped to deal with uneven multiple payments as they have a cash flow or CF function. This function will require that the future cash flows be input in the sequence in which they occur. But in business world, unless you're taking a certification exam that requires a calculator, or strongly recommended that you use a calculator for those certification exams, typically in business, we will be using the software program Microsoft Excel or some sort of other spreadsheet or data analytics tool. Thanks for watching.